Verifying trigonometric identities, explained by Justin D'Souza. The learning objectives of this lesson are to verify trigonometric identities by transforming one side of an equation into the form of the other side. And then we will verify trigonometric identities by transforming each side, that is both the sides of the equation, into the same form. We will look into both of these objectives in this video. And to transform one side of an equation, we will understand much better when we solve a problem. But before we go to a problem, you will have an equation, a trigonometric equation. You might feel that if it's a complicated or a huge equation, it's tough to solve. In fact, that is the part where you need to start solving, because if it's a simplified one, it is very hard to get the other side. So try to take the complicated side and then reduce it and simplify it to the other side. Before starting to solve, let's look into the formulas which are most important in this. We have already been through the quotient and reciprocal identities many times, even in the previous lessons. These are the Pythagorean identities in terms of cos and sine, tan and secant, and cot and cosecant. So if you know these, it's more than enough. The remaining ones we will look in the next video, in the next lesson. Now we move on to the first problem, that is to verify this identity. Now let us take the left hand side and simplify and get the right hand side. Now we can even solve from here, but it will be much harder compared to what we will do now. For these type of problems, you have to substitute and solve. It is very rare that you'll be given options for this. This is generally a writing problem. So let's start solving. So when you see such a problem, you must always remember the conjugate type of problems. Conjugate is, you can't solve this anyway. You can solve it different ways, but the most simple and the easiest way is the conjugate method. That is, in the denominator and the numerator, you need to multiply whatever is there in the denominator but changing the sign. That means over here we have sine squared theta, right? Here it is 1 minus cos theta. Multiply and divide by 1 plus cos theta here to the same first equation. Now you're not unbalancing anything. This is divided, both are divided, it's equal to 1. So it's balanced, you're just manipulating it. Now I won't write the equal to over here because we need to get this answer to that. Now here you can recall a squared minus b squared formula is always given by a plus b and a minus b. So now this is the identity which we will use over here. You can see it's a minus b, a plus b. So it will be, the above term will be sine squared theta multiplied by 1 plus cos theta only. But in the denominator now, we can do 1 square, that is 1 square is 1 minus cos square theta. So this is how we get it. Next, what can we do is, here if you look at the right hand side, this is what we need. Okay, we have got it, but how to cancel the sine square and 1 minus cos square? Let's recall the Pythagorean identity. Sine square theta plus cos square theta equals 1. Now I want 1 minus cos square, so take this cos to the other side. It will be sine square theta equals 1 minus cos square theta. Now over here in the denominator, this is sine square theta into 1 plus cos theta. In the denominator, instead of 1 minus cos theta, just write sine square theta. That's from Pythagorean identity. Now this cancels, you're remaining with 1 plus cos theta. That is what is the right hand side. So this is how we can solve it up. Please remember all the formulas and substitute, and you can easily solve it up. So that's the answer. Now we can try one more problem. You can practice this by yourselves. You can pause the video now and practice it, and then you can continue the video over here. See, this one is not a straightforward problem because over here it's minus and over here it's multiplication. So what happens? Now, this is not an actual rule, but as a thumb rule, as something that helps you to solve, which I personally use. Whenever there are trigonometric functions other than sine, cos, and sometimes even other than tan, simplify them first. So what I'll do is over here, instead of writing cot, I'll write cos square theta by sine square theta minus cos square theta. The right side is what you need to get. This, let us leave it. Now, this is what I will do. Why? Because cot is there, isn't it? If there is cot, it's not sine, cos or tan. So those are the first ones which you need to solve. Now, once we get this, here cos and cos is same. Cosine, cosine square, both are having square. So take that out as common term. Cos square theta is removed out. You'll have 1 by sine square theta minus 1. This is what's remaining. So then, what is, now this is cos square theta. Yes, we got multiplication. Now, how to make this a cot square theta? What is 1 by sine square theta? We know cosecant, CSC is 1 by sine with the angle theta and theta. So what we do is cos square theta remains. This will become cosecant square theta because it's 1 by sine square minus 1. Now from Pythagorean identity for cosecant and cot, we know it is cot square theta plus 1 equals cosecant square theta. Now take this 1 to the other side, it will be cot square theta equals cosecant square theta minus 1. So this is what happens, it's cos square theta into cot square theta. And that is what, it's multiplication. So you can write any of this first, it's fine. Cot square theta into cos square theta. This is how we can easily solve this up. Please try to apply the formulas, understand the formulas, and then rearrange, simplify, and solve it up. Verifying trigonometric identity. Over here, there is a hint that you can even verify trigonometric identity working backwards. In the sense, from this side, you can come up as well. You can just see over here, just the previous step, and then yes, you can come back. It's up to you, but whichever is complicated, try to solve that and you can easily obtain the right side. So this is what it is. And now we will quickly see another problem. It's just to simplify. How would you do it over here? You have 4 options. If the options are given, there is a shortcut method which I'll tell you in some time, the calculator method. But before that, let's see this. Cos, let me keep it as it is. But cosecant, what I'll do is I'll write it as 1 by sine theta. And what about tan? For now, I will leave this tan as it is, tan theta itself. Okay. First things are whatever is not sine, cos, and tan. Other than that, simplify them. Now I can see this is cos divided by sine. So this is equal to cos theta by sine theta in the numerator and then divided by tan theta. But I know cos by sine is what? Cot theta, right? Now this is the thing. Here, look at the options. Is there anything in the denominator? No. Everything must be in the numerator, right? So this denominator must come up. So what is tan theta? It is cot square theta by 1 by cot theta. Sorry, cot theta, not square, cot theta, that's cotangent, divided by 1 by cot theta. So what's happening is over here, cot divided by 1 by cot. So this will be reciprocal. Over here, what happens? Cot will remain multiplied by this comes up, cot theta divided by 1. And when you solve it up, it will be cot square theta. This is the answer. Now here it's option number C. That's the answer. Now there are other ways also to solve. You can just take this cot as down. It will be, see over here this step. You can write cot as 1 by tan theta into, there is already a tan theta in the denominator. Yes. Then this will be 1 by tan square theta. And then 1 by tan square theta is cot square theta. It's up to you. You can have different variations. Okay. Now I will show you the calculator method as well. Let's take out our calculators. Here, when you're using trigonometric function to solve these, you can keep it in either radian mode or degree mode. It's fine. Okay. But always be mindful. Don't take, degrees such as, if you're taking degrees, the default mode, don't take 90 or anything that is undefined. So assume a theta value. It's up to you to assume. What I would generally suggest you is Assume, say, 10 or 15 degrees. Assume theta is equal to 15 degrees. You can go with 0.5 as well. That's fine. You will get answers. Now substitute this entire equation, but only thing is you need to put theta as 15. I'll directly substitute theta as well. Cos 15, close the bracket, multiplied by cosecant. Now how do you write cosecant? It's 1 by sine, that is cosecant. And lastly, we have over here tan 15. What's the answer? It's 7 plus 4 root 3. Okay, or 13.928. Now this answer must be whenever you put theta as 15 in all the 4 options, you must get this. Only one will give you the correct answer. Let us see over here. This was 7 plus 4 root 3 at this theta. Now let me just substitute and solve for all these. What is cot? 1 by tan, and the angle I considered was 15 degrees. Is it the same? No. Let me change this. From here, let me go to cosecant. Cosecant means it's 1 by sine. Is it the same answer? No. And let me do tan, 1 by tan square. I need to square it whole. Go over here, or you can put the brackets and square. Yes, this is correct. And we also got the same thing. But let's try the other one as well. Last one, sine. Let me change this tan to sine. That is cosecant square. No, it's wrong. So which is the correct answer? It's only cot square theta. This is how we can easily solve it up. And here, these are all the methods. There are different methods. Over here, they have directly substituted and simplified. It's up to you, whichever method you can use. And now then, we will go to the next question over here. That is tan square theta into cot square theta minus cos square theta. So again, the method varies. Now what I would personally do is, I would just multiply this inside. Why? Because I know these both are inverse, right? So what's going to happen over here? It will be, if I multiply that inside, tan square theta into cot square theta minus tan square theta into cos square theta. What is exactly tan? Now you can just change this, but over here now I need to simplify tan. So tan is 1 by cot square theta into cot square theta, or you can write tan square into 1 by tan square, because cot is 1 by tan. It's up to you. Now don't write it as 1 by cot. There is no use. We have cos over here. So what I'll write is tan is sine by cos, right? So that's the thing, cos square theta into cos square theta. See, you need to strategically use the formulas. I know tan theta is equal to 1 by cotangent cot. I know also tan theta is equal to sine theta by cos theta. Now, if I do it in the first case, sine theta by cos theta, it's no use because it's not going to cancel cot out. So I wrote cot theta. Whereas over here, if I put 1 by cot, it's no use. So I have to put sine square and cos square. Now I can cancel it out. See, this cancels. Here also, this cancels. So you're remaining with 1 minus sine square theta. What is 1 minus sine square theta? From Pythagorean identities, we know sine square theta plus cos square theta equals 1. Take the sine to the other side. It's going to be cos square theta equals 1 minus sine square theta. So this is basically cos square theta. That's the answer. That's option H over here. And you can even try the calculator method and you can get the correct answer as well. We will just do the calculator method and check the answer. Over here, now you need to type this. So it's tan, let's take 15 degrees itself, tan square theta multiplied with, what is cot? It is 1 by tan 15 and square it up, minus cos is directly cos 15 the whole square, and close the bracket, and the answer is 2 plus root 3 by 4. I'll just keep it in my mind and I'll solve this as well over here. Now this is 2 plus root 3 by 4. What about cos 15 the whole square? 2 2 plus root 3 by 4. It's the same answer. Whereas if I change this to any other, so let me just change this to sine over here. It's not the same. It's minus now. It should be plus. Now if I change this to tan, oh no, this is wrong. Only one is the correct answer. That is cos square theta. And that's what we got as well. I hope this is clear. I think so some other method is used, but they have just substituted, they have applied the formulas initially and then done it. It's a bit longer, but you get the answer. This one I feel is much easier what I have written over here. Very simple steps and you can easily get the answer in 3 steps itself. So now transforming each side of an equation. Now sometimes it's easier to solve both the sides and get to a common place, because it's very hard from one side to go to the other side directly, but you can simplify both the sides and solve it. It's up to you, but these problems can be solved just now, whatever we did, the same methods. But anyways, we will see this transforming both the sides. Now generally, I'm not a big fan of these. I just take one side and solve it all entirely. That's fine. But now let's see over here what's happening. How can you start solving it? Now, when I look at this to the power 4, I know for sure this is too huge. I need to get it down. I need to, over here you can take secant square theta common out, but over here you need to use some identity and get it down. That is a square minus b square. What happens? That is a plus b, a minus b. Now, if you look carefully, it is 1 square, or it's 1 only, right? Minus tan power 4, but I need in terms of only whole square. So what I'll do is tan square theta, it's square the whole square. Okay, this means it's power 2, again power 2. So this is what I got, tan square theta the whole square. This is 1 square. Now I can apply this as 1 plus tan square theta 1 minus tan square theta. This is the simplification for this. It will be 1 plus tan square theta 1 minus tan square theta. Now here, since power 4 is big, I'll just take this power secant to the power 2 theta outside as common term, and you will just remain with 2 over here minus power 2 is gone, power 2 is remaining, so it will be secant square theta. So this is what remains. Now I can get I'm getting a clarity. What's the clarity? Over here, I need to get these two in terms of secant. That's fine, because I know Pythagoras theorem that tells us tan square theta plus 1 is equal to secant square theta. Now here I can directly apply this. See, tan square theta plus 1 over here directly, secant square theta. But what about this? Now here, there's a problem. You can't rearrange and get 1 minus tan square. No, it's only for 1 plus tan square. But I know tan square theta can be written as secant square theta minus 1. So I will do that over here. See, this 1 remains minus. Instead of tan square, I'll write secant square theta minus 1. Then this side, let it be. It's the same thing. I'm not going to simplify it further. Now here, multiply this minus sign inside. So what's going to happen? Left side secant square theta is same. Here it will be 1 minus secant square theta. Minus and minus is plus 1. 1 plus 1 is 2 minus secant square theta and secant square theta. Is it the same at the right side? Yes. Secant square theta into 2 minus secant square theta. Now you can multiply it inside and get this particular equation as well. That's what I personally would do. But anyways, you can just, trying to, implement what they have told in the question. That is transforming both the sides. So this is how we solve it. Let's just check the answer. Yes, that's okay. Sometimes method might vary, but the concept will be the same. Just 4 steps and you'll get the answer. See, these right side, what I'm writing is the formulas. These are very important to know. Only if you know all these formulas, you can easily solve them. And over here, we have one more problem. Why don't you please pause the video, try it by yourselves, and then continue watching it. So now I will solve it up. I've got cosecant, cotangent, left side. What I would personally do is I would just see now right side, right? I can see they're inverse of each other. What is cot into tan? It's 1. Why? Because cot is 1 by tan theta into this is what? Tan theta. This cancels to 1. Now this is easier. If I know right side is 1, whatever I do, I just have to simplify all this and get 1 left side. So let me substitute. Cosecant is 1 by sine square theta minus, what is this cot square? Cot square is cos square theta divided by sine square theta. Now from here, I know these both are common, so I will take 1 by sine square theta outside, and what's remaining? 1 minus cos square theta is remaining. From Pythagorean identity, we know cos square theta plus sine square theta equals 1. I have 1 minus, so take this cos to the other side. It will be sine square theta remaining here equals 1 minus cos square theta. Here, instead of 1 minus cos square, just write sine square theta into sine square theta. This cancels off and you're remaining with 1. Yes, this is equal to 1. Both the sides are verified because both sides are ultimately 1 and 1. This is how we can do it. They have done other steps, but same thing. This is the answer. I hope this is clear. It's very simple. So in such cases, I would definitely do simplify the right hand side, and left hand side we don't need to bother much. We can directly get it over here. Rather than if we had to, get in terms of tan and cot, you can do it. It's not a big deal. You should just multiply other formulas and everything. But this is more easier to solve by transforming both the sides in this case. That's the end of this lesson. I hope you have found it helpful. Please make sure you know the formulas, understand the formulas, and solve them by applying all the different identities. Now, before I finish this, I just want to tell you, please do consider subscribing to my channel. It would mean a lot. The reason why I always ask to subscribe is because more than 90% of the viewers are not subscribed to my channel. Subscribing is free. And if you do subscribe, it would mean so much to me. Thank you guys. And I wish you all the best and happy learning. See you in the next video.